Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to continue our stock prediction workflow. So we're using Tensorflow to predict the Google stock. And something special today, we're going to add in some economic data. I collected a whole bunch. We're going to use some of the best features that I found. Really, I have 400 other ones, but we have a lot today that we're going to use to complete it. And I didn't set up all of them, so you will have lots of chances, opportunities to experiment with the other features that we're not going to use today. Okay, so we're going to pick up where we left off. And so we don't need to do a lot of the maybe tedious type of work in terms of engineering the time series features like we did with the seasonal decomposition. So most of that's done. We will need to get some features from our economic data, but much reduced, and we won't need to do most of it. So starting off by importing the data comes right from the Google, or it's right from my reservoir, sorry, so you won't need to load up any files and stuff, so nice and easy. We can see here, classic data, open up, high, low, close, adjusted close body, okay? Getting the shape. So we start off with a lot, but we're going to engineer a lot of features, and we're going to create a lot of null values that we're going to have to get rid of, and that's going to make this a lot less that we're actually working with today, but this is a good starting point. And it has to do with, I don't have quite this time frame for my economic indicators. I don't go back quite this far. This goes back, I think, 10 years. I think I have a little bit less than that. So, live and learn, I should have gone back further. But anyway, so we'll use the economic data that I have. And I think economic data really shouldn't add some value to our predictions today. We found that the features we've engineered from the time series to be helpful, but really economic data. And I think one of the future projects will involve NLP, because I think understanding Donald Trump's tweets are probably very important for the stock market. Okay, so here we go. We're going to do the same thing we've done before. We looked at the distributions in the histogram plots. We're now going to import our economic data. This as well is in my reservoir, so we're just downloading it from there. And we have average weekly hours, challenger job cuts, unemployment rate, 7-year note, core CPI month over month, federal interest rate, Bloomberg consumer confidence, Michigan inflation expectations, and a handful more. You don't need to read all of those. So we're going to use a handful of them today, not just to keep this workflow a little bit simpler for the video, but have fun with the rest of them. See if you can find out some secrets that I missed, because that would be, and then don't forget to share them. Okay, so we're going to see this. We're looking at before we combine it, we're going to do a little bit of pre-processing. Okay, so we're going to, we have a few of our data set that just didn't have any values with it. So we're going to drop those, get rid of those to work with. And we inspected it by looking at the data frame, looking at one of the columns of null values, is null, and dot head to logically index those. But you can see here, it starts right at the beginning of our data frame, index 0, 2006, January 1st. So this is really at the very beginning. So we're going to have to drop a few rows today, and we'll try to minimize that, but we'll have to get rid of it. So, okay. So we have 3,700 rows, and what we're just going to drop the null values, keep it a little bit simple today, but it's in the past. So we can't really fill it with the median, because how would you have known what it was in the past? You can't fill back. So I guess you could, but I think that would add a lot of bias. So we're not going to do that today. We're just going to drop our null values, because they happen at the beginning. They happen before we have data to fill forward, because what we want to do, the economic dates, something was released this day, and we fill forward on those dates. I pre-processed this a little bit for us, so it's filled forward because that's the value that was recently released, but we can't really go back in time. Okay, so looking at the columns, looking at what we have now right here, making a short little list of this. I'm changing the column names a little bit to make sure the date index name lines up properly. So I got the column names. I copied this and I changed it to date, which is the same name in the column we're going to merge on in our other data frame. Okay. Everything else is the same. And so what we're going to do is we're just going to set df.gb.columns, and we're going to set this to the equal. So just a little pre-processing do. We're going to do pd.merge. And don't worry, we're going to get to the coding that we're all going to do together. Okay. So we do that, we do the head. I just want to make sure that we go through the stuff that we've done before. We'll go quickly through this. We're going to look at the indicator development that we did before, fast stochastic, and visualize those indicators. Okay. And then we make those stationary. And then we're going to look at the economic features right here. Okay, so we have a list of the economic features. We're just going to take them out of the data frame right here. We make a little list, look at those. And what we're going to do, you can see here when we look at those, we have K, we have the percentage sign, we have the letter B, and we have a handful of things. We also have the letter M. So what we're going to do is we're just going to replace those names with no values, and then we'll do this as well. We'll get rid of all of the values. To get rid of them, I just went through a little bit tedious, so I just did that for you. So just replacing the columns, just get rid of those. And then what we're going to do is we're just going to convert this back to a float. So all those values that we removed, we cleaned up, we're going to turn them back into floats. And you can see now we have all of our new economic data. It's all the correct data type as a float. Okay, we're just going to drop the null values to make sure that we have those. So we created a seasonal decomposition plot before, and we looked at it with the MACD, the RSI, the FAST-K, FAST-D, which is the denominator, and the percentage close to. So we did all those, and we looked for patterns, and we extracted the days that show a really high correlation. Like here, the 5th day. We have lots of patterns here. The 2, 3rd, and 5 days those show that they have a good correlation with the present. So this is autocorrelation. This looks at where the correlation really lies and extracts the seasonal component from that. So we did all those. We need to do something similar with our economic indicators. So we don't know if the economic indicators is released kind of before that end of the day. We really won't know if we have it available at that time. So we need to use the past values to predict the future. And so what we're going to do is we're going to go for. So we have a list of features, and you can see here I have a lot more that you'll be able to play around with. And I found these ones were valuable. I didn't want to spend the time doing them in the video. So we have these videos here and something fun for you guys to play around with. So we're going to go 4 feet in economic feature. And so this will workflow. You just have to uncomment these, and this workflow will work the same with those. Okay, so workflow. And then what we're going to do is we're going to go put in our seasonal decomposition plot right here. So the thing that we made up above, right? And now, so if we forget what the arguments are and how we spell them, we could go up and look, it's just up there, but we could just also put a question mark here, and we know we have FRQ equals 5, so that's what I wanted to be the frequency, and then the lags, LSG, so that shows. Basically what I'm saying here, LGS, okay? So what that's saying here is I want a frequency of really to show as much. So I think here is the pattern in economic indicators usually lies in a 5-year cycle. So I'm basically kind of saying as close as I can reasonably with the amount of data I have, saying a 5-year cycle. And I'm just showing up to 4 in the past. And so what this is going to do is going to look for correlations. Let's say 60 days in the past is kind of correlated with the future. Shows a interesting correlation there. Something at 230, 240 shows a correlation. And I went through every single one of these. Some of these are kind of hard to figure out. Unemployment rate doesn't really seem to show a good one, but I wanted to use it a little bit because it does seem to have something to do. So I used smaller amounts for the unemployment. You can see here core CPI. There's a few days that show a little bit. So 250, for whatever reason, shows a higher correlation with our target, which is quite interesting. And we can see that the federal interest rate is most correlated in the recent past. So I made a list of these features. This was something you have to do. If you add new features, you would have to add these in. Okay, so what I made a list of those features. Okay, and then what I do is I create a list of tuples here. So MACD, MACD days, RSI, RSI days, FAST-K, FAST-K days. Okay, so doing all of that. And now we want to do our new feature. So just for practice, since we get to do something here, what we're going to do is we're going to do the way that I did is copy and paste. I think it's good not to copy and paste in practice, but in this sense, it made it a little bit easy. And so I'm just going to paste right here. And what I want to do is delete the underscore days from the title. So we can just have Fed rate decision and then the days. And it's good to think about how you're going to copy and paste your coding because it will actually make it easier. It's good to practice whenever you can, build that muscle memory, but sometimes it's good to plan how you're going to copy and paste your code as well. Okay, so we're going to go 4 days in weeks, days. Okay, so we're going to go through this list, and then we're going to go for D in days 1. So what this is just to explain what's going on here. So we're going 4 days in features. So we're going through each item, each tuple in this list. And then when we get to the second for loop, we're going to go is for the number of items in the second position. So 0 is the title, second position is this list that we have right here, these lists. So then we're going to loop through this list. Okay. And what we're going to do is days, and we're going to select the first position. So selecting from the first for loop, just this position, the name that we want to go. So we're going to change the name and we're going to go D. This is going to be equal to the days in the past. So day in ago. So we're going to organically change the title. And then in this next one, we're going to go days and again position 0 because we're selecting this column here and we're going to shift it by the days. Okay, so there we have a nice little for loop to do all of our, make sure we run the self above, to do all of our feature engineering. And then when you can look ahead and we have, look all the way to the right, we have all of our new days. And we can see we have quite a new features. Just to select it here, I select a few of them. So you can see unemployment rate 5 days ago, and we would see it's the same. The thing is the reason we had to do bigger time cycles on the economic features is because this is not only updated once a week, once a month, and we're filling forward. So it's going to be, lots of the days are going to be the same. It's not changing as dramatically as the stock market changes. So we have to be aware of that. Okay? So we're going through that and we're showing this. So that, let's go to the next one. Okay, so we're dropping the rest of the null values. So is null, because there are some, we engineered their features that we created some. So is null and some right here. Okay, and we'll see we do have a few that. So as I thought, we need to get rid of those. So drop NA. And really, again, those are in, we would probably fill forward with those days. So we don't really have a way to fill those in. So it is what it is, but we have to really drop those to be the most correct. And this is for the stock market. So we want to be, hopefully to make money, we want to be as correct as possible. So here what we're going to do, I want to just show an easy way how I set up my workflow going into the model section. So here what we're going to do is I looked at the df.columns. We have a lot of columns now, and I like to select the columns right before I go into my modeling workflow. And so what I'm going to do, so in the features, I'm just going to paste this whole list of features. So we start with the MACD 1 day in the past, going all the way to the federal interest rate 50 days ago. So 2 months ago, basically, and see how that impacts our model. So we have all of those there. And it's just a quick, easy way. And this allows me to, if I decided, well, I don't want to use these ones, so let me just comment those ones out and I'll try my model. The rest of the workflow will work the same. And this allows me to experiment and really see which features I should be using in my model. Okay, let's do this. And then we're doing the split, and then we're doing the iLock. And we're doing, sorry, and I should explain this. We're doing a time series split. So we're just splitting. We're going to use the old days to train them, and we're going to test on the new days. So we're creating a train and test data set. I believe we've done this in the past videos, but just in case you've forgotten, just wanted to explain that. So, and then we're going to look at make sure there's no null values, and we have no null values data set. Okay. Here, what we're going to do is we're going to create our X and Y for our train. So from the DF train and the DF train again, we're going to select the X features and the Y from the target. And we're going to do the same for the test. So we do that for both of them. Okay. And we want to do, this is truly, it's always important to do this standardized. So although we've done this many times before, I just thought it would be good for us to continue to practice with this one, because this is something you'll do for every workflow. So here we're going to go standard std underscore scalar, my kind of what I like to use. And so we're going to go scalar, and we're just going to fit this as we're initializing this object right here. And so now this is going to be the standard scalar. And then we're going to go standard scalar. And we're going to go trans test. We're going to transform both of those. And you can see we have 80 features. It's quite a large amount of features. Okay. So we're going to import, just to make this a little bit, we're going to build a big function here. Well, not super big, but a decent sized function, especially for data science purposes. So what we're going to do here is we're going to import layers. So we don't have to go tf.keras dot whatever, and we're just going to import layers, dot layers, dot, and then layers. So just to make it a little bit easier, we're just going to import the layers, and so we won't have to write as much, make it right. But in this first one, what we're going to do is we're going to go tf dot keras dot models dot So we've got quite a few, quite a little bit long, the kind of standard syntax for TensorFlow. Okay. So here what we're going to do is we're going to do an if statement, this little section right here, to include either an LSTM, a GRU, or a simple recurrent network. So whichever one works best, we're going to experiment with them. Because we're trying to find the best architecture. It's really hard, truthfully, to find the best architecture. And really, as much as you can understand about the mathematics, it really comes down to experimenting to really fine-tune your model. And if you're not familiar with the mathematics, more experimenting is better to gain that intuition around what is actually happening to your model as you're changing these things. So it's really just good to understand and see how these things will impact our final model, because they really do make a big difference. Okay. So here we're doing our if statement. We're going to go model dot add. This is a good type of syntax for the sequential model when we're just going to be using it in a loop so that we can kind of do this if statement stuff. Okay? So then we're going to do layers dot LSTM, and then we're going to do this one activation, activation function. There we go. Okay. And so we're going to go input shape there, and it's going to be our dimension that we created up above, and 1. So that works with the recurrent members. Okay. Then we go else if. So elif, the current layer is the GRU. And I should explain just quickly before we go through. I put all of our different possible hyperparameters up here. We're going to go through this in loops. So this is going to be recurrent activation. Recurrent type is going to be our LSTM. So our current type is LSTM, which is the default to do this layer. And these are all the different hyperparameters that we're going to be looping through, that we're going to be experimenting with down below. So to explain that, that's going to be going in. And we have to be aware of these. It gets a little bit big when we're doing this, because we're going to also be needing these to put into our outside function. We're going to be building is our model factory that makes the architecture of our model. But then we want to set up our experiments to kind of automate this a little bit. So call these a little bit lighter and down below. Okay, so just to make sure I explain that and didn't just keep talking, rambling without explaining what's going on. So here we're going to do is elif recurrent layer is equal to SR, the simple RNN. And if that happens, what we're going to do is we're going, and to finish off the second one. So if this is the GRU, we're going to do GRU, and we're going to go the input shape right here. Okay. In the third one, what we're going to do is model.add layers. And here what we're going to do is simple R. So we're right there. So nice and easy. This will make our model a little bit easier really to work. We'll be able to add these on the fly, and we'll be able to loop through these and just kind of test it all. So then what we're going to do is for num dense body, num dense head. And so the number of the dense layers or the number of the dense head layers. I find that it's kind of good to experiment with the amount of dense layers, and then maybe some large ones, some small ones, or some small ones and then large ones really do make a surprisingly big difference. And so I think it's good just to separate the ability to control how we're going to put those dense layers together. That's all we're doing here. So we're setting how many dense layers for our body, and then we'll be followed by a head. I'm just giving them 2 different names. So one set of dense layers, and then the next set of dense layers. So we can play around with different architecture. We're going to model.add layers dot dense. Okay. And we're going to go model.add again, and we're going to go layers dot dropout. Okay, dropout, so important, truly, just incredibly important. It surprised me how, really, truly, how important those really are. And so here what we're going to do is our range, and just make sure there's no space after this range. It's really important. Okay, so range and range, we're going to do this, and this is creating a list. So we're going to go through one, we're going to do this once, or we're going to do this twice, or 3 times, 4 times, or so on. So as many times as we want to. And we'll experiment with a few different ones of those. So we'll go model.add, and we'll go layers.dense, and we're going to go here, we're going to go activation. To our dense activation that we have right over here. So ALU is what we start with, and we'll play around with different ones. Okay? And then we want to make sure that we add the dropout layer after each dense layer. I think that's just a good kind of practice to add that. And then we need our output layer, which is our kind of prediction layer. We really only have one neuron on this layer, which is going to be our linear regression that's going to predict the stock market, hopefully. Okay, so then we're going to go model. Regardless of what we did below, we're always going to go model.add layers dot dense. We just want a dense with one. Basically, at every neuron, it's basically a linear regression, then it passes through an activation function. So one neuron is just that one linear regression output. We're going to then do the all-important compile our model. And we're going to set our loss equal to the LS, the loss function up here, MAE. We're going to set our optimizer to our optimizer. And we're going to set our metrics equal to a list of the metrics we want to use. Okay. And so this is using the TFA add-on library, metrics r squared. And so what this is doing is just giving us back r squared as well, which I thought is usually how you would value a regression one. So it's not a default one in Tensorflow, so you have to use their add-on library, but I think it's quite nice in this, especially in this workflow. So let's run this. Make sure the errors perfect. I like when I don't see errors. Okay. So here we're going to set up the model experiments. And this first one, the way to think of this, oops, sorry, and I missed one thing here though. So we want to make sure that we return the model. So we compile the model, and then we want to return the model that we compiled. So it's going to return a compiled model that we can set up, we can then run through the loops in our experiments. Okay. So this is going to set up the model building. Now we're going to set up our experiments. So what we're going to do, let's just copy and paste this, is going to take our model factory function that we created above, and we created it, so I think it's okay to copy and paste those. And then we're going to set recurrent neurons, recurrent activation. We're going to set that equal to these functions. So this one will then we'll set 78, and 78 will then be passed to this number, and that will be passed to the function inside the model factory. So that will be overriding these initial defaults. Okay, you just have to be careful to connect these. That's the way this function works. Okay, in the simplest way to do this, that's how it works. So then what we're going to do, so we get our model from the model factory, our compiled model. So we're ready to do the model.fit. And we're going to X train, Y train. We're going to train it for so many epochs. We're going to do a validation underscore split. And then we're going to set verbose, because it's going to be in a loop, so it's good to turn off kind of all of the, you just see so much stuff, truthfully. So validation split and verbose. Okay. Then the best way to plot this is using data frame. So putting the history that we created from a model.fit. So we're going to go history dot histories history. Okay. And then we're going to go plot on that. So Pandas plot is really quick and easy thing to do. And then we're just going to show this plot. And this is going to give us nice line plots. We're doing layout. So we're doing 4 subplots, and we're doing 4 rows by 1 column. Okay, so we're going to be nice and easy to look at. We're then going to do model.evaluate, and then model.evaluate again. And that will be the evaluate for the train, and then evaluate for the test. Okay. Then what we're going to do, we're going to get this train, this score train. But remember, we have 2 things in there. So we need to go score train 0, the first position, which would be the MAE, which is our loss function. Then we're going to go score train, and we're going to do position number 1 here. Oh, sorry, I added an extra thing. We only need to add a 0 in this. And then in the trains, or sorry, the test score, we just need to add a 0 into this first position to get the MAE from the test. And then to get the R squared, we just need to add a 1. Yeah. And so, because this would take a really long, a very, very long time, and I have 1 extra, I had to get 1 mistake. Almost made it through. And now I have 1 extra function right here that's going to output these. So we got these. Now we have our 2. We have our inside function, our model factory, and then we have our outside function, the model experiment, that really is going to perform the experiments on the model factory that produces. Okay. So here is just me running the model experiment for the first time. You really could run it without any functions and then all default, so we just run the default settings. I found a good way to store this though is to set it up, set all of the parameters out here. We're going to go through each experiment. I'm going to change this after each experiment. So just to keep track of it, because it is quite a few and there's a lot going on. So we're going to set up a loop here. We're going to get the two blank, we're going to get train scores, we're going to get our test scores, and we're going to get ends. So whatever we're looping through, basically. So it could be different things in different situations. And we're going to put those into a list and down below. So we're going to print out what it is. So print out what we're looping through. We're going to do first our recurrent test. We're going to have 30 to 60, get 5 of those. We're going to print those out. So we get all of those. And then we're going to append results to our train scores, and then our score trains, and then our append our test score to our score tests. And then we want to append what we're doing into our function. We want to append this into, and we're going to use the line plot function that was created up above, and we'll use this again. Created up above. And so here we're going to just make sure we do int. So we're going to set our index to what we appended when we're going through our loop. Okay, so this will work pretty much the same. And here we just want to set title to equal to test. Okay, so, and we can see that here. So now we have our experiment set. I'm not going to run this because it's going to take forever to do all of these, and we have a lot of them. So I do recurrent layers, and what I do as I go through, I find the best score, and then I find, and I run another experiment right here. I'm going through the activation functions. And then here what I'm doing is going through the different types of recurrence. So I kind of looked at all of those together, and then I wrote down what I found is the best one. And really it's just going through which one has the best. We're not going to get 90s here, guys. This is not that easy. Truly, it's pretty tough to predict the stock market. I have not been successful yet, but I'm still trying. And well, hopefully you guys can help me. But so what we're going to do here is just look for the best ones. We're looking for the best architecture, and we can see here are the best test one was this one. This test, this simple RNN gives a bad test score. LSTM worked the best. And so I put LSTM, I put the 10 activation function and 45 neurons. If we went and looked at the neurons in the first one, so I find it going down to this one. In the situation 45 test, the first time I ran it, this looks 40, 45. Really, this would be the best one right here. So this one's getting the best score that we received, the best R squared. And I went through all of those. I kept going through them and going through them and going through them, and I collected this. Then I would do the dense test right here and do the same thing for the dense. I loop through it, and I'm looping through the number of dense layers, then the number of dense neurons, and I loop through all of those, and you find the best ones, and then the number and the activation function. So there's a lot of tests to run really to go through this. And I do that, and then I add to this little, I guess, list of my hyperparameters, which ones were the best. And then go to the next one, the next one. So I do the head next. It was very interesting that the head dense layers, the best one turned out to be 55, and then in the body, the first layer would be 120, and then 55 after that, and two 55s, which I found very interesting. Okay, so going into the epochs is really important because we don't want to squeeze too hard on our data, because we'll get really bad predictions if we overtrain our model, if we overfit our model. And it will tend to overfit quite easily. So we really want to stop it as soon as we can, as soon as we see that we're getting. So we keep going through that, and we found that 100 epochs makes a lot more sense than other ones. And then we're going to test the learning rate. So testing quite a few of them. And one of my favorite ones is 1e -6. I find that works the best. And this is just one more zero versus this one right here. So it's 6 decimal places to the left, or to the right, to go back to that. Okay. So when we're going through that, and we go through all of these, and now I have a list of my final architecture. So then we run our final test, and we get our scores, and we get that, and we can see here that I have final scores. So I wouldn't say I got a great score or anything like that. Nothing super fancy on this. I think it takes a lot of experimenting. We did something very, very basic here. And I think there's a lot of opportunity here. We can see that a lot of the times the score did actually sometimes in the 0.4 lots of the time. So we just need to make sure that we mimic that as much as we can. I just only had so much time to run through this so many times. This involves a lot of experimentation, especially with the creation of the time series features and which economic features actually add value. So we'll go through one of our next projects in how to select features, a good, really interesting way to do it with Shapley values. But here we go. We're almost done our project, and hopefully we're going to get to predicting the stock market. So thank you again for joining me on this third part of our stock prediction project with TensorFlow. I will see you next time. Bye.